class. Uh, so we are going to study our yesterday's what we did yesterday. So yesterday हमारे पास we had we related two states, vacuum states को भी या two states whether they are being acted upon by annihilation operators or creation operators. So annihilation operators को किसी भी annihilation operator A in terms of A or A dagger in terms of A dagger, two states, how we can relate them for non-particle states or for given vacuum states. We had a certain relations and certain how to relate that space in a Fock space that we described that. In today's class, what we are going to see is we are going to have algebra of algebra of algebra of you can say algebra of creation and annihilation operators. So algebra of creation and annihilation operators means that, for example, the first step we have to relate the algebra. For example, अगर हमारे पास creation operators होंगी, for example, in the sense AI dagger, creation and annihilation operators. For example, creation operators are like AI dagger and AG dagger. Yes. When applied to a successive state, produce the same physical state. Although normalization may allow it to depend on the order in which two particles are created. For example, for one particle state, A1, A2, A3, so particles of the same kind. So अगर हमारे पास अब creation operator or annihilation operator acting on that state, it will hop to the next subsequent state. So उसका जो place value है, it will go addition to it. तो हमारे पास जो कोई भी state होगी psi, so if we have two AI dagger, it's being applied, it's being psi is being acted upon by two creation operators, AG dagger and AI dagger. Then so we can have if you have so if you want to once it will act, it will become it will reach here. Can say it's a form iron acid. AG will become that here and AI dagger will come here. You can see. So we can relate two creation operators acting on state psi can be related this via some scalar multiplication. अब अगर हमारे पास ये है where I and J are two subscripts. So अब ये है कि it's advantageous for one particle representation chosen. And how we can relate one particle representation with the other particle representation, such that if you remember yesterday, we had a very important equation. For example, how we could relate two creation operators as LQ. This is the inner product. This is a creation operator को दूसरे creation operator के साथ via this. You can say it's inner product or its unitary transformation. How we can relate one creation operator with another creation operator via unitary transformation, which may be an inner product or which may be an operator. You can have it's a matrix also. You can say that way. It's a row and column also, or you can say it's an operator form. It's an inner product or unitary transformation by which this creation operator can be related with this. In the same way, for annihilation operator, you can have Ki goes to L2, it's B. So ये दो equation use करते हुए, if we are going to use them here. Now here we have AI dagger, AJ dagger. So here AI dagger, AJ dagger के बदले हम लिखा BQ dagger, BJ dagger. ये दो बदले. In the same way, we are going to do proper substitutions of AI dagger and AJ dagger here in terms of this. So it will come out to be, if you see पहले इसको AR diagram के साथ substitute करो, फिर AJ diagram के साथ substitute करो, so we'll have the terms in the BQ diagram in the form of, so we'll have terms like this AI diagram. फिर you substitute first AI diagram, फिर AJ diagram, and then subtract the two. The terms will come out to be AI diagram, AJ diagram minus lambda AI, AJ diagram, AI diagram, acting on psi will be equal to K of L. So now you can have these two terms from both sides, this and this. So it will be L of Q K into Ki, L of L into Kg. It's Bk dagger, Bl dagger minus lambda times Bl dagger, Bk dagger psi is equal to 0. So the transformation coefficients or arbitrary, the transformation coefficients or arbitrary complex numbers except for the constraints which are imposed by unitarity. तो हमारे पास आप देखो यहाँ पर हमने, if you remember that we had two relations yesterday. एक हमारे पास creation operators के लिए था, एक annihilation operators के लिए था. So in the later case we got a Kronecker delta in terms of K and L, such that Ki Lk into Lk Ki can be written as, so Lk is a unitary, it's like inner product, it's like Lk and Lk, so it will be 1. So you can say Ki, if it's Ki and it's Kg, K inner product of Ki, Kg can be written as delta Ig. So if it's delta Ig, so you can see you here. This is Ki, Kg is delta Ig. This will come out to be sometimes K is equal to L, it will be 1. So Ki, Kg is delta Ig multiplied with this factor. So if you say it, you can see the things. Yes. You are hearing. Students are hearing. So students are hearing. Hello. Hello.
Yes, sir.
Yes, sir.
बोर्ड दिखाई दे रहा है?
हाँ sir, हाँ.
So you can see it. So if you have any problem, so you have this AI diagram. This you can say, so it's a Kronecker delta. तो हमने कुछ नहीं किया. What we did, we had how we can write एक हो गया एक creation operator in terms of creation operator in a given basis state for one particle state. इस तरह annihilation operator को हम दूसरे annihilation operator में कैसे how can relate the two annihilation operator for one particle states. अब वही चीज हमने किया, अब दो annihilation creation operators acting on state psi, so they will lead this thing AI की जगह AJ आएगा, it will be displacement आएगा. So you can relate two creation operators acting on state psi. You can relate multiply it as a scalar. अब yesterday हमारे पास वो ये relation थी ना, AI को in terms of this, how can relate a two creation operators, this is a unitary transformation. two annihilation operators with a unitary transformation. So I substituted these two equations for these transformations, and we got equations in this form. अब हमारे पास for annihilation operators we could also have जो bracket notation में I so it will be delta ij. So if it's like that, then we can say that uh, then we can say that जो हमारे पास ये है बी के बी आई बी ए डैगर बी के डैगर माइनस लैम्डा टाइम्स बी के डैगर बी ए डैगर इज इक्वल टू जीरो. You can say L ये है ये वाली equation KG. So if it's zero, so you can say this is equal to this equation can be equivalent to zero. So if this equation can be equivalent to zero, then you can say B as so if it's equal to zero, then also you can say B and dagger, BK dagger. So if it's equal to zero, so from this you can extract the value of lambda. Lambda is a scalar. So lambda is plus 1 or it can be minus 1. Lambda can be plus 1 or it can be minus 1. If you can extract the relation from there, this is the algebraic way of doing the same things. So from this, if it's plus minus 1, you can have two commutation relations. Either lambda is plus 1, for example, इसका हम complex continuation लेंगे, तो it will become plus or it can become minus. So if it becomes plus or minus 1, we can have two commutation relations. एक commutation relations है, if we write B in terms of A, so B is the creation operator in terms of B is equal to A dagger, जो भी उसका inner product. A is equal to A dagger in terms of A is equal to A, some inner product. B dagger is equal to B dagger via some inner product. So how can I write two creation operators or two annihilation operators? So for example, annihilation operators for a given value of lambda, there can be two plus minus values. So वहां से we can extract two commutation relations. A commutation relations will be, for example, if it's for B or it can be for A. For example, for A, we can have A J dagger because we are now going to write B in terms of A. So B in terms of, so for example, A dagger is equal to BQ dagger LQ KI and AI is KLQ into BQ. So you are going to write A in terms of BQ. So we are going to substitute A. So we can write this commutation relation can also be of this form. Now we can have this form. For one second. One second. So all right, students, what? The students are here. So if it's like this, so it's how we can write a two creation or two annihilation operators in terms of, so we have two commutation relations. A commutation relation आएगी for a commutator. A commutator आएगा ऐसे, will be minus, or and this will be a commutation relation. And we will also have anti-commutation relation. So AI dagger, AJ dagger, plus AJ dagger, AI dagger is equal to 0. So we can have a commutator as well as an anti-commutator in both cases. So these are commutation relations as well as anti-commutation relations which we can arrive at. Or yes, we can have. So you can see this is a unitary transformation. So we can have restrict unitary transformation for one particle states which belong to certain subspecies in that sense. So if you take Hermitian adjoint इसका लेंगे, इसका भी Hermitian adjoint लेंगे, इसका भी Hermitian adjoint लेंगे. The equation will take it will have form, it will have the form AI dagger, AG dagger minus mu A, sorry. So it will be of the form AI AG minus AG AI is equal to 0. AI AG plus AG AI is equal to 0. So, so for a similar argument, we can be made for two operators, AI and AG dagger, with I not equal to G. If you consider AI AG dagger, psi can be written as. So a similar argument can be made for the argumentation we have done here. We can be making a similar argument if for I not equal to J. So for I is equal to J, तो हमारे पास ये आएगा. So for I not equal to J, you can see for annihilation operators वहाँ हमारे पास Kronecker delta आ रहा था. For I is equal to J, you can arrive at this thing. For I not equal to J, there can be again we can go through this exercise, but वहाँ पर हमने scalar को lambda से define किया. Here we write it in terms of mu. Now we can have AJ dagger AI psi, and unitary transformation will be you subtract both of them, AI AJ dagger minus mu AJ dagger AI psi can be written in terms of जो हमारे पास जो we had a unitary transformation in terms of inner product. So, doing that algebra, I'll straight away write it. KL, you can write it K times LT and LL times KG, BK, BL dagger, B times BL dagger, BK into psi equal to 0. So in satisfying the condition, in satisfying the condition, satisfying this condition, which is equivalent to this, you can have like this. You can have like this. So now in the previous case, this was equal to 0. So for I not equal to J, it may not be necessarily equal to 0. We can keep a constant here. This, for example, LK for a K is equal to J, it will be 1. So Ki Kj will be delta Kj. You can see it that way. So you can say it can be equal to A. Such that the BK dagger है minus mu BK dagger BK is equal to A. Or if you write BK in terms of AK via जो हमारे पास relationship है, how we can relate to creation and alienation operators. BK को in terms of A and BK dagger in terms of AK dagger. So we can write it this equation can further be written as AIT dagger minus nu times AI dagger A is equal to E. Or this is equal to this. So AI dagger minus nu times AI dagger I is equal to 1. अब ये हमारे पास whatever we have done, it's for example, occupation number for nth states. What is the total occupation number? जो हमारे पास, if we have one particle states, they are operating on that Fock space. What is the occupation number in that? So that may be constant. It may be n. N is I. For one particle state, it may be 1, or it may be this. So it will be n. It will be n. Or you can also have, for if it's for k constants, you can have this. So other then a trivial identity operator, you can have one identity operator invariant under transformations. Invariant under transformations. So AI dagger, in terms of AI, we are going to write AI in terms of AI dagger and BI in terms of BI dagger. So you can write it like this. You can write this thing. You can write this thing. So you can write it in terms of this thing. And say that AI dagger AI is going to BE dagger BP. And AI dagger is going to BQ dagger. So this is the basic algebra of which is invariant under commutation relation 21.7. So it's invariant under commutation relation commutation. So let me summarize what we have done today. You are listening? Hello? Hello?
Yes, sir.
Yes, sir.
सुन रहे हो?
Yes, sir.
You are listening?
Yes, sir.
So what? Let me summarize. हमने आज क्या किया? What we have done today is basically we have done is जो हमारे पास हमने पहले and yes, I'll start with what yesterday we did. हमने one जो Fock space है या Hilbert space है या जिसमें हमारे पास जो basis state है. So there can be one particle states, two particle states, and particle states. One particle states means particles of the same kind. ठीक है? उनका क्या है? हमने उन पर, for example, we operated those one particle states. They are denoted by psi. उस पर हम either creation operator act करेंगे or they are being operated by destruction operators. अब यह है कि two creation operators on this space. How can relate अगर एक creation operator इस basis state पे act करेगा? How can it will go to some other state? How can relate two creation operators which are acting on a given space or given subspace? इस तरह how we can see two annihilation operators acting on a given subspace? How can relate them? अब उसमें यही है कि we have to relate them via some unitary transformation. जिस तरह हम कोई है ना psi is equal to aij psi k है ना, how we can relate psi and size in terms of some unitary transformation. So in the same way, how we can relate two creation operators or two annihilation operators in terms of some unitary transformation. Unitary transformation को हमने in terms of inner product bracket formalism में लिखा था. ठीक है? Once we did those substitutions, proper substitutions in the entire process, we finally at the end arrived at two equations. उनका form और या commutator हमारे पास आएगा. One is the commutator form और दूसरा हमारे पास anti-commutator आएगा. This and this एक plus form में आएगा. And we could summarize this, how we can write the algebra of creation operators and algebra of the annihilation operators. This is what we have done. उसका form, commutator का form कैसे आएगा? एक anti-commutator आएगा एक, and we also have A in terms of B, AI, and B in terms of A dagger in terms of A dagger, B in terms of B. A dagger in terms of A dagger multiplied by some unitary transformation. B in terms of B multiplied by some unitary transformation. So entire procedure को हमने we have arrived at this thing. ठीक है? So anybody has to ask anything? So अब ये है कि you just look towards the book and see the algebra. You try to see it. The idea is same. Only thing is कि जो हमारे पास अगर हमारे पास वैक्यूम स्टेट है, वैक्यूम स्टेट पे अगर क्रिएशन ऑपरेटर एक्ट करेगा या इनिलिएशन ऑपरेटर एक्ट करेगा, it will be zero. So you can always relate any two creation operators or any two annihilation operators on a vacuum state. You can straight away relate them. The point is how can relate for one particle states. अभी हम one particle states लेंगे, मतलब of the same kind. How we can relate them a given subspace in which we can relate two creation operators or two annihilation operators operating on a given state. Psi, which is part of some space, vector space, Fock space भी हम उसको कहते हैं, ठीक है? And जो space है ना वो basically state psi है, psi पे act करती हैं exactly. So should we stop? Hello?
Yes, sir.
Okay.